Are you able to see my screen?
Yes, it's clear.
Yes.
Okay, thank you. Now, for the last couple of lectures, we have been focusing on styles, the architecture styles, and inshallah we'll look at these ones today as well, and we'll try to uh, you know make a bit more progress on covering of them. So just to refresh the minds, we are talking about some very basic common architecture styles, and of course there are quite few of them, and we are planning to only cover one sample style from each different category. The other day we covered the client server architecture style on Thursday, which basically is a style where you go on and you have two layers. You have clients and servers. It's a bi-directional information happening between clients and servers, and something which is very popular in the industry. Your clients cannot talk to other clients, and there are other constraints in this style. The other one we learned the other day was the pipes and filters, where you have individual separate programs, which are your filters, and then they share information among themselves by using the pipes. So basically, a filter gets an input, does its functionality, generates an output. That output is passed on to the next filter as a sequence in a linear way, uh, you know, uh, as an input for the next one via the pipe, and so on and so forth. So it's a one directional, or it's a unidirectional flow of information in the pipes and filters, and each filter is actually a separate program. And the third one we learned the other day was our blackboard style, where basically you have individual programs, but these programs are connected through something called knowledge base or blackboard. And again, that these independent programs don't talk to each other at all. They all talk to the blackboard or the knowledge base, and accordingly that information is or data is shared among different independent programs. Any questions on these three styles before we move on to today's one, which is our interpreter style? Any questions on the first three ones? Everybody's comfortable with these ones, right? I think so. Okay. Now let's go to the interpreter style. Now, this style is different from the first three ones we have seen. And the reason it's a bit different is that it's the nature, the application of this style. Here you have something called interpreter parsers. Okay. And you have something called interpreter. And what it does, interpreter does, it actually parses and executes the input commands. So in this style, what really happens is that you have commands, and those commands are parsed and executed by the interpreter. And of course, as a result, it goes on and updates the state maintained by the interpreter. So this interpreter also goes on and updates some values, some data for variable or whatever, So basically, it also updates the states maintained by the interpreter. So what do you think? What are the components in this case? What will be the components in this system? So if you are using an interpreter style, what probably will be your components?
Maybe an interpreter and the commands.
Yes, the interpreter and the commands, definitely. So basically, for sure, you will have interpreter, and you will have these states, because this state needs to be maintained. So this will be your one of the component, and you will have user interface, because this is from where you will get the commands, right? So this is from where you will get the commands, and then of course the key thing here is the interpreter, which is the most important and unique thing to this style, and of course the state as a result of this parsing and execution of the commands. Now, when it comes to connectors, uh, your usually typical procedure calls, normal procedure calls, or shared data is used for connecting these components. which is the data which is being passed between components? So what will be the data element in this style? Your data elements will be commands. Okay, so like for example, in client server architecture, the data elements was the information which was being passed between clients and servers, right? Here, what is passing between different components, the user interface, the interpreter, and the state, is basically the commands, because commands are being given via the user interface. Interpreter is parsing and executing them, and as a result is going on and updating the information. So the data element which is passed in this style are commands. And your topology is typically tightly coupled three-tier, which means you will have a user interface on the top, and then you will have your interpreter in the middle, and this interpreter at the end of the day will go on and update the states. So it's a tightly coupled three-tier. So you got to have these three tiers, and they need to be organized in this way. So this is, this topology of this style. What do you think? Where is used? Or what are the examples where you will have the interpreter style?
Compiler. You mean
Compilers,
like system?
yeah. Yes, compilers. Yes, absolutely.
And command prompts.
Command prompts.
Yes.
Any other example? Any other application where you might have seen this style?
Could it maybe be database? I don't know, maybe.
Fair enough. Maybe any other place thinks of where this thing happens, where you give a command and it executes and goes on and changes some data, some information. Excel macros, right? Excel formulas, right? Isn't it?
Yes.
Right. So as you guys said, more like compilers, all different applications which has kind of compilers kind of a mechanism, right? Where you give instructions and it goes on and uses this interpreter to go on and parse that commands and execute them, and as a result go on and update some state values, are typical examples where this interpreter style is used. Now, I'm pretty sure everybody is now comfortable that how, for example, interpreter style is different from a pipes filters. Right?
Yes.
Yeah, because there is no interpreter in a pipe filter, for example. Everybody, I believe, is comfortable that it's different from client server, right?
Right. It's clear.
Yes, good, alhamdulillah. Now I have a question for a client server, because sometimes I get confused. I said, okay, in a client server, yes, I know it's a two-tier architecture style, but I can still do this, right? In a client server, I can have a user interface, all right? And then I can have within a server, I can have a business logic, and then I have a database. So is this a an interpreter style?
Since you have a database, it shouldn't be an interpreter. I think.
I think of it as the data that I'm using, sharing. Here, I will be sharing information, but as you said in the interpreter, I should use the commands. So I think it's a different now.
Exactly. So basically, here the data is passed back and forth is the information. Here is the commands, and then as a result, since it's commands, like Excel commands, like take a sum or if conditions or whatever, right? And you have something called the interpreter, which is very unique to this style because these commands are parsed and executed by them. So hence the two styles. And the reason I take this example deliberately is because it's very easy for us to be confused sometimes if we're not very clear conceptually by looking at the topology, by looking at the layers, and we say, oh, well, you know, they looks very similar to each other. But actually, it's the concept of the way, you know, what is happening inside it, which makes them different. Hope this is clear to everyone, right? Okay, alhamdulillah. It's not that difficult, by the way. So again, you know, just a dummy example here. So basically, you have your user interface, and then you have your interpreter, and then you have your states. So this was a style which we were supposed to cover the other day on Thursday. So let me share the next round of slides with you guys, and we'll take it from there, inshallah. Now. Okay. So we'll just continue this one, and we'll talk about a different architecture style now, which is called publisher and subscriber architecture style. Now, what happens in a publisher and subscriber architecture style? So far, before I talk about, just to very quickly understand, we talked about client server architecture style. We talked about pipes and filter architecture styles. We talked about the Blackboard one, and we just finished the interpreter one. So we're done with 4 different types of styles. Now we're looking at the 5th one, which is the publisher and subscriber. Now, what happens here? That you have subscribers, and those subscribers register, or of course deregister, to receive specific messages or specific content. So basically, you know, you're looking at subscribers, and those subscribers will register to receive certain messages, certain data, certain information. And these publishers actually broadcast these messages to subscribers either synchronously or asynchronously. All right. Can we think of an example here where this is typically happened? Again, this style is absolutely very common. It's some, I should be saying,
Like
it's a very common one.
like YouTube, maybe.
Mm-hmm.
Oh,
Suggestion of the YouTubes, right?
yes.
Anything else?
Maybe notification.
Sorry, one by one, please. Yes, Saud, go ahead, please.
Maybe notification, like for example, notify me if there is something new, and when something pop up, he notifies you.
Exactly, something new, some notifications. Yes, absolutely. Anything else? There was someone else who said something.
Yes, Doctor. I think it's heavily used in the declarative design patterns for the UI design.
Yes. Where you have a lot of notifications happening, right?
Yes, data is flown from upstream to downstream.
Exactly. What about the video games? Where you have notifications happening in a multiplayer network game scenario? Probably that's another example, right? Where, as Abdullah said, you know, you will have different notifications happening, right? In a user interface, for example. So this style, actually, you know, to be honest, this style is very heavily used and something which is very, very popular. And you will see it in most of the applications. Now, another point to understand here is that publisher subscriber style is a good example to understand another very important concept. Publisher subscriber style on its own will be used, and you may have an application which is purely using publisher subscriber, but it's something very rare nowadays because overall the applications are more complicated. So you will find that publisher subscriber is used as a part in to do a certain task within a system, and overall the architecture of the system could be client server. So actually, it's a very good example of a style which kind of, you know, clarifies one more concept, that you as an architect are allowed to combine these basic styles to create architectures for your system. Is this point clear to everyone? That you are allowed to combine. So you basically can combine client server and publisher subscriber styles, or you can combine, layered ones, the virtual ones, which I didn't talk about, but for example, virtual ones with client server, or basically you can combine all of them as long as you're able to justify. Is this point clear to everyone, right? I mean, you are allowed to combine these basic styles to solve your problem. This goes back to my example of 2-story house, 10-story building, where basically, you use the basics to solve the problem, and then you are allowed to combine and innovate as well. So let's continue with publisher subscriber to understand this one. So what will be the components in this style?
Publisher
Mm-hmm.
and subscriber, and I think
Yes, absolutely. So publishers and subscribers, absolutely. And sometimes, because in more complicated applications, one publisher is not able to handle all subscribers, so probably he may have proxies for it, right, as well, so to manage the flow of the information. The components are publishers and subscribers primarily. What will be the connectors? How they share information?
Through a stream?
Through streams, so usually through a typical network protocol, right? And those network protocols are used to share these messages or contents. Of course, this as someone says about the YouTube example, or maybe even, for example, the Amazon or other places, you can even have, or news, for example, right? The news feeds. Basically, they can be even content-based subscriptions as well, right? So basically, they are more sophisticated. So they're not just normal network protocols. They could be even have a bit more, sophistication about, what kind of content needs to be passed on to a user who is more interested in, soccer or football, while compared to someone who is more interested in an NBA or a basketball, and so on and so forth. So these connectors, these network protocols, could be simple network protocols passing on these messages or contents, or it could be a bit more sophisticated. But at the end of the day, you have publishers and subscribers. Their subscribers are registered to publishers. Publishers are pushing information to subscribers via these simple or a bit more sophisticated network protocols. Of course, what is being passed between them is your subscriptions, these notifications, the information. This is what is being happening. This is what is being shared between the different components of your system. And the topology is very simple. Subscribers connect to publishers, either directly or through their, from proxy. And the variations are possible. For example, one variation is that specific type of style may require particular steps of subscribing and subscribing. So some of them may require certain kind of information for you to subscribe or unsubscribe that information, or it could be more complicated in a sense that it's actually using the logic and learning from the behavior of the user. So maybe based on your interest that you're watching certain kind of YouTube videos, like for example, you're watching videos on Premier League, then it kind of understands that this user is more interested in Premier League. So next time it will start sending information about notifications about football YouTube videos, for example, right? Is this variation clear to everyone? That you can have a case where you subscribe to CNN, and then CNN will send information to you, or it could be the other way around, that YouTube is kind of monitoring what kind of, or Amazon kind of monitoring what kind of things you are purchasing, and then it starts sending notifications according to your interest. And this style, again, as I said, this is a very popular and heavily used style. And you might have by now realized that this style typically is used as within a more complicated overall structure of application.
But could it be used alone, like standalone?
Yes, it can be. Yes, it can be used standalone. Absolutely, it can be.
Okay.
Right.
Fine.
For example, I'm not sure whether this is there anymore or not. RSS feeds, right?
Yeah, I don't think it's used anymore.
Yeah, it's not used anymore, but they were a good example of publisher and subscriber. right, on their own.
Yeah, it was popular at the past time. Yeah.
Yes, yes. So yeah, yeah, you can even use it on your own. In reality of the world is in more complicated systems. It will be used maybe for notifications within an overall client server architecture, probably, right? Because if you look, for example, the what we call, for example, Amazon or eBay, it's overall the structure is more like client server architecture, but within it, notifications will be done through publisher subscriber.
Yeah, yeah.
Like a broadcast. So basically, it's the best thing about this style is it's very efficient one-way dimension information. So it's an efficient way of one-way, sending or disseminating or dissemination of information, and very loose coupling. Amazing thing about this is a very loose coupling of components. In other words, I have 10 subscribers, and they are getting this information through a publisher in one direction, a lot of information flowing. Now if one of them leaves, no problem, rest will still survive and it will keep working. Or maybe another one joins, or another 10 or tens of hundreds of them joins, that's okay, as long as it's no issue with the bandwidth. It's very, very loosely coupled style. So it's very different to, for example, which was the tightly coupled one we just saw? The interpreter, right? Remember, there was a 3-tier tightly coupled component architecture style where you have to have a user interpreter, you have to have an interpreter, and you have to have a state. Here is very loose coupling. Publishers, you need to have at least one subscriber, at least one publisher to survive. You can have multiple publishers, you can have multiple subscribers, and it will just keep growing, shrinking according to demand. We talked about a lot of applications of it, video games, basically anywhere where you have notifications. This is something which is applicable. Now, even from a programming perspective, this is also something which is used. This style is used in large scale systems, which supports basically commercial middleware technologies. So middleware actually, from a programming perspective, it's a computer software that provides services to applications beyond those available from operating system. So it's more like a glue code. So basically, like services provided by Android operating system, for example, right? So Android is developed on top of a Linux kernel, correct?
Yes.
Yes, yes.
Yes, and then it actually, but it gives you its own services as well, right? And those
Right.
services, if it's like some notification, some kind of service on top of the Linux operating system itself, so they also use these kind of systems also use publisher subscriber to send one directional information or data or command or data basically or information to different other applications in the system. So publisher, again, this is heavily used, very, very popular style. I think everybody's comfortable with this now, right?
Yeah, right.
Alhamdulillah. Okay. Okay, let's move on to the next one then, I think so. Again, this is just an example, a dummy example, subscribers and the server, your publisher. The next one which we're going to talk about now is something called event-based architecture style. As the name suggests, this is all about, some events will be generated, and when those events are generated, others are notified accordingly. The independent components, they asynchronously emit and receive events communicated over an event bus. So you have independent components, And these independent components, they are generating events, and those events, or maybe they are receiving those events generated by other components, and they talk to each other or they communicate to each other over something called event bus. Over something called event bus. So what do you think? What are the components in this case?
User interface maybe,
Mm-hmm.
and independent component, like for example, I don't know for real, but maybe receivers
Yes,
and something to emit. Maybe.
Absolutely, absolutely. Now let's take an example before I explain it. Let's say, for example, anybody has used Java Swing APIs?
Is it like DevFX?
Yes, I used Swing, but long time ago. I don't know.
Ago, right?
Yeah.
Or something similar now. Basically, what happens there? They have, they have the action listeners, right, or event listeners, right?
Yes.
Right. And what happens there? There are
You
different
need to
programs.
handle the event and so on. These kind of things.
Exactly. So there are so many different independent programs, right? Independent components. They are continuously listening to those events, right?
Yes.
And as soon as there is an event happens, it just goes on and reacts to it, right?
Absolutely, yes.
Right. So such systems, such are examples of an event-based style where basically, you have independent components and they are emitting events and they generate events, and then of course you listen to these events, and of course they all talk about through something called event bus. So your components are these independent components, and they have some kind of event generators or consumers as well. So at the end of the day, they are all these basically independent components, and they talk to each other with something called event bus. So then you got to have at least one event bus here. So if I have to draw a structure of it, it will be something like this. You have these independent components, and they're talking to each other via an event bus. Now, does it look very similar to your Blackboard, or is different from a Blackboard?
I think it's different because it happens locally, I think.
The major difference is what? It doesn't have a knowledge base. It's topologically, it looks like something in the middle, which is allowing you to communicate, because in the Blackboard style, each independent programs were talking to that Blackboard, right? But here, yes, they are independent components. We're not using the word independent programs here. We're saying independent components. So this could be subsystems or individual systems in a very big enterprise system, right? And there's no such thing as a knowledge base here. What you have here is something called event bus. At least one event bus needs to be there for it to work. And then these different subsystems or systems within an enterprise are communicating with each other via the event bus. Is this difference clear to everyone?
Yes.
Okay. Can we think of maybe another example? Now overall, lately, this basic style has evolved, of course. So you have something called SOA, or service-oriented architectures, right? I'm not sure whether you guys have heard about it. Or you have your enterprise architectures using even web services and all of that stuff. Now, let me just for an analogy, just for an example, let me give you another example. I'm pretty sure you guys have seen the Tawakkalna application now, right?
Yes, of course.
All right. Now for that application, if you look now lately, especially the new releases they have done, it just not just to tell you information about your health status, but it also tells you a lot of other information, right? It gives you about, you know, what vehicles are registered under your name, right? Have you seen that?
I didn't use
Sure.
it a lot, so I'm not sure.
Yeah, but it shows you nowadays, it shows you information from different sources now, right? So it gives you information from Ministry of Health. It shows you information from Ministry of Interior, right? It shows you information from the Traffic Police Department, right?
I think also they used it for the madrasati.
Exactly,
Okay.
for schools as well, right?
Yes.
Right. So basically, what's happening here is that they are all of these systems, Ministry of Education systems, Ministry of Health systems, traffic police systems, they are independent systems. But they have developed an infrastructure where they get information from these different ones and like a portal show it to you. So they are using, it's not exactly like event, but they are basically using it as a service-oriented architecture and web services to basically grab information from different systems and share it and pass it on. And when you refresh it, you know, it kind of, you know, goes and sees whether there has been, you know, any update and so on and so forth. So these are are examples of systems which basically, you know, allows you to connect these independent components and share information by generating events and let other programs or subsystems or independent components listen to it and react to it. Okay. So basically what is being passed back and forth are your events. So you're generating events. And then, you know, data is sent over the event bus. Events could be, you know, requesting certain information, right? Or updating it or whatever, right? Topology again is very simple. The one I have just drawn here. These components, these independent components communicate with an event bus. They do not directly talk to each other. So they don't talk to each other directly. So like similarly, clients cannot talk to clients, or even in Blackboard, different independent programs don't talk to each other. They talk through the knowledge base. Here again, in event bus, these independent components don't talk to each other directly. They only can communicate with each other via the event bus. Of course, you can have a bit of variations there. This event bus may push or pull information. In other words, you know, it can periodically get information from these independent components, or these independent components periodically push information to the event bus. So that's possible. It's highly scalable. It's highly scalable. It's easy to evolve. That's the biggest strength about it, and it's very effective for highly distributed applications. How? What do you think? How is scalable?
We can add more components to listen for an event. Like here we have 4. Maybe you can increase them.
Exactly, like our Tawakkalna app. Today they have the Ministry of Education. Tomorrow, if they want, or maybe it was the case, to be honest, in the beginning, it was all about the health information. Now they have incorporated the vehicle information and the Education Ministry information. So they basically can keep adding more, and or they can start even removing them without really disturbing the overall structure of the application. So highly scalable. Uh, why it's effective for highly distributed applications? Why I'm saying it's effective for highly distributed applications?
Maybe because they need to evolve, they need to get bigger.
Yes, so basically, you know, they are able to evolve. They are able to they're able to enhance, and of course, this is suitable for distributed applications because these different systems are usually going to be independent systems or subsystems. So health systems, interior systems, education systems, and they are all distributed applications. So they're not residing in one place. They are all distributed across the network, across the cloud even, and basically, you're using this information to really update and scale and so on and so forth. Is this clear to everyone? The idea behind this one?
Yes, but Doctor, is saying highly scalable the same as loosely coupled? Or there's a difference?
Ah, good one. Okay. When we use the term loosely coupled, it will mean that if you detach, the system will still work, right? And highly scalable is again inherently are loosely coupled, right? Because you can scale it, but this really means in a sense that this event bus can, depending on the capacity, and of course these event buses have capacity. That's why we use at least one, because you can start adding more event buses and you can start adding more of these subsystems as well. Right?
Yeah.
And of course, hence they are easy to evolve. This is just a structure, the one I just showed you. You can have so many different components and they can be sharing information back and forth through event bus. And of course, you need to have at least one event bus. Okay. Any other questions, guys?
Doctor, isn't event-based style, is it like model view controller or not?
Good one. Now, let's see if I have a space here or not. Remember the chart I showed you the other day where I said a design patterns here, right? Then we had the styles here, right? And this was all about the structure of the application, and there was the depth of the application domain you need to know. Now the MVC as a as a pattern, as a design is gonna be somewhere as a design pattern. It's gonna be at this level. Okay. Now, I think your question was that is MVC similar to event based, right?
Right.
Okay. In an MVC pattern, what happens? You have a model, you have a view and a controller, right? And information moves from your view to the model to the views to controllers to the views, right? Back and forth, correct?
Correct.
Now there is no such thing as a event bus in that style, in that pattern. It's more like you're tightly coupled or three layers, model, views, and controllers. While in this style, you have something called event bus, which is allowing you to connect different independent components. So they're completely different things. Here you have something called event bus, and this event bus is giving you the scalability.
Okay.
Okay. It's a good question, actually. Yeah, it's a good question. Any other question, guys?
Yes, Doctor, I have a question, please.
Yes, Khalid, go ahead.
Related to, for example, the Tawakkal application. In the initial release, I have downloaded the application. It doesn't work, only the login page. So if I try to log in or register, there's no other page. So is that related to the event-based style or does not relate?
Yeah, Khalid, somehow the voice was not very clear. Can you repeat the question, please?
All right. For the token application in the initial release, only the first page, which is the login or register page. If I try to log in, the page doesn't show me another one. For example, the verification code or the home page. Is that related to event-based style?
So in other words, if I understand your question, you're basically saying that that app, when you register, it doesn't show you any verification, right?
Yes, in the initial release.
In the initial release, and it was just showing you the page, right?
Yes, only one page.
Only one page, which was all about the health information, right?
Yeah.
Yeah, or the permits,
Yes.
the walk permits and all that kind of stuff at that time, right?
Yeah.
Okay. Now, see what's happening here is that it's actually, to be honest, that app is more like an enhanced or evolved version of the event-based architecture style. Okay, where you are basically using service, probably you have using something called service-oriented architectures, where you are creating everything as a service, right? So all these independent programs like Ministry of Interior gives you so many different services. Like you can, for a given national ID, you can get his vehicle information, you can get his uh, whatever different informations, right? And they use those services as a portal. So they use, for a given ID, they go and query those subsystems individual, because they are independent systems, and they send information. They sort of queries who say, give me information about this person from a interior ministry, or from a traffic police, or a education ministry, right? And then once those information comes, they kind of present it in that page for you seamlessly. So under the covers, they are using something more like an enhanced version of this one, where basically all of these subsystems actually are connecting through certain service bus.
Right.
And hence they are able to communicate with them. And hence it's seamless. Like even in Upshare, for example, right? Same thing happens in Upshare as well. That they are different programs. Everybody has a complete control over their own system, but they provide you certain services, and then the app uses those services to get information for each individual.
Got it.
And this is something which is very popular nowadays. This is something which is very this is architectural decision. This is your architectural design decision, right? And actually, this is now will make a lot of sense. I think the example I always been quoting since we have talked about architecture, the 1-story house, the 2-story house, the 10-story building, and the Burj. See what is happening here is that these are the styles I'm discussing today, and probably because it's not a completely architectural course, so that's why we only talk about basic styles in this course, because we need to cover so many other things. These basic styles can be evolved when they have evolved, right? Because the things became more complicated, and the same idea was evolved into something called service-oriented architectures and web services and so on and so forth. All right. But fundamentally, this is the basic style.
Right. Doctor, the point here is that the application doesn't work in the initial release, only one page. So what's the benefit of releasing this initial release? Did you get my question, Doctor?
Yeah, I got your question. Now, see, this is what is happening.
So why did they put it in the App Store, for example?
Now, see what's happening here. But probably they had this vision, right? So they already had that vision, probably, right? And basically, they kind of structured it with very bare minimum, stuff, and probably they had service bus under it, because actually, to be honest, service bus is already there in the infrastructure of the government subsystems. It's already there. Upshare works like this. So basically, what they were doing is, in the beginning, just to give only one part of information, they just put it, that basic one information that, it's just whether you are green or red or whatever, right?
Right.
And then later on, because the service bus is there, it's just a matter of for them is to, decide that, okay, now we want to share the vehicle information in the same app now, right? So they just enable it. So that's because it's highly distributed, scalable, they just enable it.
All right.
So yeah, so probably, they just released that one, and we don't know what decisions they were taking, to be honest, but probably my feeling is because they already know that they have a service bus, and I know they have a service bus. So basically, at the end of the day, otherwise these systems will not work. Otherwise they will not have this enterprise view.
Got it. Got it.
Right. Yeah. So that's why these architecture styles are very scalable.
Thank you.
You're welcome. So I think we're running out of kind of time here. So let me use maybe 2 minutes to talk about a bit of project. I think there would have been some questions. I'll make a bit more announcements in the Blackboard announcements, just to make everybody comfortable about what needs to be done here. But since we're here, let me just explain the very first phase of the project. No. Let me share this one, please. Where it is. Okay. Can you see the screen now, right?
Yeah.
Yes, we can.
Okay. Now, I have given you an SRS document, right? This SRS document is written by another team. My idea behind giving you an SRS document is to mimic or kind of simulate in a situation where you're actually designing applications for requirements written by someone else, like an industry. And B, I know those requirements, and they are some class diagram decisions they have taken have some problems in it. But we will look at them later. Well, first of all, in the first phase, you just go on and do an architectural design. So basically, you will go and look at the requirements of the system, and then you will say, what are the 3 possible styles which can be applied here. Then you comment on each one of them, and then you talk about the one which you believe is the most appropriate for their system. And then you will go on and create something called deployment diagram. Now, what's a deployment diagram? I am leaving this as a task for you guys to do a bit of Google search on it, bit of research on it, and see what we mean by deployment diagrams. Okay, so this is deliberately here. Now I'll put all of this, because we're running out of time here. So probably I'll put all of this information into